These are solutions for the Newton's second law worked problems. The worksheet in your packet that's labeled number 2, F equals MA problems. We're going to work on number 4. Calculate the force needed to accelerate a 3.5 times 10 to the 5th kilogram jumbo jet at the rate of 6.1 meters per second squared. I've written the given information down to the right. Your mass is in kilograms, your acceleration is in meters per second squared, and we're solving for force. So let's go ahead and write the equation down. Force is mass times acceleration. Let's go ahead and plug in 3.5 times 10 to the 5th kilograms times an acceleration of 6.1 meters per second squared. Be careful how you plug this into your calculator. You want to make sure that you use parentheses when solving. So we end up with an answer of 2.14 times 10 to the 6th newtons. An experimental rocket sled was developed to see what accelerations a human could undergo and still survive. During a test, it went from rest, now remember that is an important set of words there, to 1,000 miles per hour in only 1.8 seconds. What force is required if the sled and person had a mass of 600 kilograms? And you want to be careful about units here. So the first thing you want to take a look at is how to find acceleration. What you're going to need to remember from our last unit is the change in velocity over time. Well, our velocity went from rest to 1,000 miles per hour, so it has changed 1,000 miles per hour in 1.8 seconds. Now we have a problem here because our units are not compatible. We have hours and we have seconds, plus typically we are not working in miles per hour, we're working in meters per second. And so as you can see in this problem, we've went ahead and given you the conversion that 1,000 miles per hour is equal to 447 meters per second. So we're going to use those numbers instead. 447 meters per second in 1.8 seconds. And if you divide those two, you get 200, approximately 248 meters per second squared. That's how much your rocket sled has accelerated. The other information that you have been given is that the mass of both the sled and the person is 600 kilograms. And we are looking for how much force it took to get the sled moving that far. So we're going to go ahead and say F is equal to m times a, and we'll take our 600 kilograms times our acceleration of 248 meters per second squared. And we get a very large force of 149,000 newtons. Write down your weight or somebody else's weight in pounds. Let's just go ahead and use a weight of 100 pounds for an example, but you can plug in your own weight. For part A, it says 1 kilogram is equivalent to 2.2 pounds. And it wants you to calculate your mass in kilograms. So we're going to go ahead and do that here. If I weighed 100 pounds, and I know that there is 2.2 pounds in a kilogram, that means that I'm going to take 100 pounds divided by 2.2. And I get 45.5 0.45 kilograms for my mass. Part B says, what is your weight if you measure it in newtons rather than in pounds? Well, I know that weight can be written this way. Force due to gravity is mass times gravity. So I'm going to go ahead and take 45.45 times gravity here on Earth, negative 9.8 meters per second squared. And I'm going to just leave this as an absolute value and say that my weight in newtons, if I am 100 pounds, here on the planet Earth, is 445 newtons. Part C says, what would your mass be on the moon, where gravity is 1.6 meters per second squared? I want you to think about that a little bit. Mass is not weight. Mass is just mass, no matter where you are in the universe. So for this particular case, my mass would still be 45 kilograms. That's an exclamation point. And then part D, what is your weight on the moon? Well, your weight would be different, and your force due to weight is going to be mass times gravity. My mass has not changed when I've gotten to the moon, so it's approximately 45 kilograms times gravity on the moon, which is 1.6 meters per second squared. So I take my 45 times 1.6 and I get about 72 newtons. A pebble with a mass of 0.05 kilograms is sinking into the ocean with a constant velocity. How big a force does the water exert on the pebble? Hint, how many forces are acting on the pebble? So let's talk about that. There's definitely a downward force, and that is the weight of this pebble. There is the force of the water pushing back on that pebble as it falls through the water. And in this particular case, we're not going to really worry too much about any other outside forces, but there could be current or some other forces acting on this pebble really in any direction. But these are just the two we want to think about right now, is the weight of that pebble being pulled down because of gravity, and then the force that the water is pushing back up on the pebble. And so what we know for sure is that it has a constant velocity. And if something has a constant velocity, that means its acceleration is 0. And what else does that mean about net force? If the acceleration of the object is 0, that means the net force of the object is also 0. It doesn't mean there aren't any forces. It means the net force is 0. And if the net force is all of the forces on an object added up, that means in this particular case that the force due to gravity, or the weight of this pebble, is going to be equal and opposite to the force due to the water. Those things are going to be equal and opposite. So if I have the force, my force due to gravity is going to be equal and opposite to the force due to the water. And so if the question is asking, how big of force does the water exert? Well, we just need to figure out the force due to gravity, which is really just the weight of this pebble. So let's go ahead and do that. So the weight is always going to be mass times gravity. The mass of this pebble is 0.05 kilograms. The gravity on this planet is negative 9.8 meters per second squared. I take that 0.05 times 9.8. I end up with 0.49 newtons. Negative, of course, because it's moving down. That's the force due to gravity. And we just said that force due to gravity is equal and opposite to the force due to water. So the water exerts a force of positive 0.49 newtons. That's an N, by the way.